This is the first lesson on A-level trigonometry, and as such it is a recap on all of the contents that you should know from GCSE, and then just taken up a notch. So, first things first, if you have a right-angled triangle, you should know that you can use either Pythagoras or SOHCAHTOA to work out some missing information. That's it on the left-hand side there. If you don't have a right angle, if you just have a general triangle, then you're going to use either the sine rule, the cosine rule, or the area rule. Now, you should know all of these formulae already, but just pause the video at this moment and copy all of those down so you have them to hand in your notes. If you have any doubts about any of these, then I'm going to put a link to a video in the description of this video where you can go and look at some examples of these. You have to be completely fluent in using these formulae. The lesson that we're going to be doing is going to be some problem solving with these. So you have to be completely fluent. If you have any doubts at all, you must go and watch that video in the description and take some notes from that. You should also know the exact trigonometric values for certain angles. So for 0, 30, 45, 60 and 90, you should know what sine, cos and tan are for each of those. For example, if I just asked you in class, I said, what's sine 60? You should be able to tell me it's root 3 over 2. If I said, what's tan 45? You should be able to tell me it's 1. You should know these. You should also be able to prove them. So a A-level question might say, to prove that cos 30 is root 3 over 2. Again, if you are unsure about this, if you can't remember how to do this, I will put a link to a different video in the description where you can go and see all about that as well. Next, you should remember the shape of the trigonometric graphs, so what sine, cos and tan look like. We will be looking at these in a lot of detail in the next lesson, but you should know the rough shape from GCSE. So again, just pause this video at this moment and copy those graphs down, copy them down neatly. I will be checking to make sure that you have got all of the key coordinates in the right place and that the sine graph goes through the x-axis at 180, for example. So I'll be checking to make sure that you've copied those down carefully. Something else that you should know from GCSE is all about bearings. I'll just go over this very quickly because I know some people struggle with bearings. Oops. So bearings are a way to give directions. They are an angle measured clockwise from north. So, for example, in this example here, I've got two towns, A and B. If I wanted to give directions to somebody in town A so that they could go to town B, I could do that with a bearing. So obviously I want to tell them to go in this direction to get to town B. Well, the bearing is the angle measured clockwise from north. So if this is north, the angle measured clockwise would be this angle here. So I don't know, roughly about 250. So I would tell that person in town A that they have to travel on a bearing of 250 degrees to get to town B. If instead I was talking to somebody in town B and I wanted to give them directions to get to town A, so they want to go this direction, the bearing that I would tell them, the angle measured clockwise from north, so there's north, this is clockwise from north, and so I think that's probably, that's going to be roughly about 70 degrees there maybe. So I would tell that person to travel on a bearing of 70 to get to town A. So that's bearings. And final thing from GCSE that you should remember is angle facts, including parallel lines. So remembering that alternate angles are equal, corresponding angles are equal, and co-interior angles are add up to 180 degrees. So with all of that in mind, let's have a look at an example question that you're going to be doing in class, which is this one. So the diagram shows the positions of three towns, Harston, Eden and Jedburgh. We've got Harston here, H, Eden here, and Jedburgh down here. we can see from our diagram that Eden is 5 kilometres from Harston. We can also see that it is on a bearing of 107 degrees from Harston. We can see that Jedburgh is 7 kilometres from Eden, and it is on a bearing of 144 degrees from Eden. The question that I'm going to be answering is asking me, well, two questions. First of all, find the distance of Harston from Jedburgh. So I want to work out this distance here, the distance between Harston and Jedburgh. So what is that distance? I'll call it X. Right, now, to help me do this, I can start to fill in some missing angles using parallel lines, because I know that my north lines are parallel. They are in the same direction. So if this angle here is 107, then I know that this angle here is going to have to be 73, because I know that co-interior angles add up to be 180. I can now work out this angle here, because I know that angles around a point add up to 360. So if I do 360, take away the 144, take away the 73, so this angle is 143 degrees. Now let me focus specifically now on this triangle. I can see that this side is 5 kilometres, this side is 7 kilometres, and I have this angle here. This is enough information for me to use the cosine rule. Again, like I said a few moments ago, we should be completely fluent with the cosine rule, so I'll just write it down for now. And remember, if you're not sure about how to use the cosine rule, do go and click the link to the video in the description and go and watch some examples of this cosine rule, sine rule. So, x squared equals my b squared, which I'm going to call 5, my c squared, which is 7, times 2 times 5 times 7 times cos of my a angle, which was 143. I'll type that into my calculator, and then I will square root what I get. And when I do all of that, I find that that distance is 11.397 kilometres. Or to one decimal place, 11.4 kilometres. So that's part A of the question. I've worked out that Harston is 11.4 kilometres from Jedburgh. Part B, find the bearing of Harston from Jedburgh. So read this question really carefully. The bearing of Harston from Jedburgh. So I'm giving a direction to somebody in Jedburgh. So I'm telling somebody in Jedburgh the angle that they need to travel on, clockwise from north, to get to Harston from Jedburgh. So the person I'm advising is in Jedburgh. They want to travel to Harston. So the bearing clockwise from north is this angle. That's what I'm trying to find out. Well, the way I'm going to do this is, first of all, I know that this angle here, I know that's going to be 36. I know that because I have co-interior angles here. And I know that co-interior angles add up to 180. So if this is 144, then the other angle must be 36, because 180 take away the 44. So I know that angle there is 36. I now want to work out what this angle here is, because if I can work out that, then I can do 360 take away the 36 and the theta, and that's going to give me my bearing. So to work out that angle theta, again, we're looking at this triangle here. And I know each of these sides. I know that this is 5, I know that this is 7, and I've just worked out that this is 11.4. So I can use the cosine rule to work out the missing angle. I could use the sine rule if I wanted to, but I'm going to use the cosine rule. So first of all, let me write down the cosine rule. And I'm going to rearrange this to make the cos A the subject. So I'm going to move the cos A, I'm going to move this over to the left-hand side. I'm going to move the A squared over to the right-hand side. So I'll get 2bc cos A is equal to b squared plus c squared minus a squared. And then I'm going to divide both sides by 2bc. So I've made my cos A the subject. Now let's put the numbers into the formulae. So cos A, or in my case theta, that's what I'm trying to work out. Now my B and my C, doesn't matter which way round we do this. So I'm going to call my B, that's going to be the 11.4 that I worked out in the previous question. Now I want to be really accurate about this, so I'm going to write down 11.397 squared. Or even better, if you've still got the 11.397 in your calculator, you can just use answer squared. My C will be 7, and the crucial thing is that the A has to be the side that is opposite the angle that you're working out. So my A is 5. The B and the C don't matter, but the A has to be 5. So I'll type all of that into my calculator. I will then do cos inverse of my answer, so cos minus 1. And when I do that, I get 15.3 to 1 decimal place. So I've just worked out that the theta here is 15.3. So to get my bearing then, I'm going to do 360 minus the 36 minus the 15.3, and that tells me that my bearing of Harston from Jedburgh is 308.7 degrees to 1 decimal place. And there we go. So that video there is a recap of everything from GCSE. Do check the links in the description if you need any recap of the cosine rule or the exact values or anything like that, because in next lesson you're going to be tested on all of these skills, so you need to be completely fluent on them.